It's working! This video is sponsored by PCBWay, your one-stop shop for quality PCBs and rapid turnaround at an affordable price. PCBWay offers a range of solder mask and silkscreen colours, enabling you to make your PCBs as individual as you are. Hello and welcome to the final video in the Duino-Coin mining series. Today I'm going to run through assembling the miners, flashing them and using them. I've designed two variations of the miner, one with a through hole Atmega IC and one with a surface mount Atmega IC, both of which I'll show being assembled. Let's start with the surface mount version. I elected to hand solder the components in place as I have neither a hot air gun or hot plate. To solder the Atmega IC in place, start by adding a little solder to just one pad. Then, ensuring that the orientation of the IC is correct, heat the pad whilst positioning the IC in place. Double check that all legs line up with the pads correctly before moving on. I found it helpful to apply a little flux to the legs before soldering them. Ensure that there are no shorts between the IC legs before moving on. If there are, a little patience, flux and solder braid will help do the trick. Next, work around the board in an order that you find easiest, soldering the rest of the components into place. Save the USB plug and the resonator until last. To solder the surface mount components, I found it easiest to apply some solder to just one pad, then, while holding the component in place with a pair of tweezers, heat the pad again to melt the solder. Again, I found that applying a little flux to the pads helped make this process a little easier. A tip when you come to solder the 4.7 microfarad capacitors into place. These need to be soldered in the correct way around, and, unlike a through-hole capacitor, the ones that I had purchased had a line on the positive leg instead of the negative. To ensure that the LED was soldered the correct way around, I used my multimeter in diode mode to identify the anode and cathode. Using some isopropyl alcohol, kitchen paper and a toothbrush, I cleaned off the vast majority of the flux. Next, the resonator and the USB plug were soldered into place. Finally, I gave the board a thorough clean with some flux remover and the trusty toothbrush. When assembling the miner with the through-hole Atmega IC, you'll want to solder the surface mount components in place first. Then clean the flux off before flipping the board over to solder the remaining surface mount components into place. Then solder the through-hole components into place. Open a terminal window and type sudo apt install Arduino-Y. You can verify the version that was installed with Arduino -- version. You can verify the Java version installed with Java -- version. I already downloaded the software in video 1, but will rename the folder to .old and re-download the software to ensure that I have the latest version. So open up a terminal window and, if you didn't already do this previously, type sudo apt install python 3 -dev git. Next, clone the Git repository by typing git clone https://github.com/revox here /Duino-Coin. Now we are ready to flash the miners. For this video, I'm assuming that you've pulled your Atmega IC directly from an Arduino, or you've purchased one that's already been flashed with a bootloader. If you haven't, then there are plenty of videos on YouTube showing how to flash a bootloader onto an Atmega IC. In case you are wondering what the ICSP header was for, it's used in the flashing of the bootloader. Open a File Explorer window and locate the Duino-Coin folder that we just cloned from the GitHub repository. Open it and then open the folder Arduino code. Double-click the file arduino_code.ino. This will open it up in the Arduino IDE. Next, insert your USB miner into the Raspberry Pi. From the Tools menu, ensure that the board is set to Arduino Uno and then select the correct port. Mine is shown here as /dev/tty USB 0. The easiest way to find out what port your miner is using is to check here before plugging it in. Then the new port is your miner. Click this button to compile and upload the code to the miner. Great, that's done. Now it's time to get mining. Open a terminal window and navigate to the Duino-Coin folder with cd Duino-Coin. ls lists the contents of this folder and we need to run the AVR miner. So that's Python 3 avr_miner.py. Enter your Duino-Coin username, and if you set up a mining key in your Duino-Coin account, enter that now or else leave this field blank. Now enter which port your miner is connected to. Remember, we found out this using the Arduino IDE, so for me it's /dev/TTY USB 0. If you have more than one USB miner, you can add it here by selecting yes. I'm going to select no. I'm not going to bother with a name for this mining rig, so I will select no. Here we can choose the developer donation level. And now the miner starts. The LED blinks when the USB miner is mining. If you want to make one of these miners but skip the KiCad part, both boards can be purchased directly from PCBWay's project area, or if you want to make a mod to my KiCad files, then you'll be able to find these on GitHub. The links for both options are in the description. Subscribe so that you can join me next time for a retro ZX81 computer build using all new parts.